Today we're going to discuss about what is CPT symmetry and what is CP violation. But before we start, let us understand what is symmetry in physics means. It is much similar to as we know in mathematics, that if we took the mirror to some line, a symmetric object looks the same. But this is not the thing that we actually consider in symmetry in physics. Generally in physics, we can explain it by a symmetry is anything where you have some sort of object and applying some sort of transformation to it, and you can't tell the difference in some sense. Let's explain it more precisely. Consider a star system and rotate it by alpha, and we would ask, is this a symmetry? So how could we find that it is a symmetry or not? Simply we would conserve the whole energy of the system. If the system has the same energy as it was before, then we would say that it is conserved. We also call this as a conservation of energy, and hence it would be proved that it will follow a symmetry. Let us take another example. If an object is rotating around our Earth at a fixed orbit, then we know that its angular momentum is conserved at any point on that orbit, which we call as a conservation of angular momentum, and by this we can again say that it is a symmetric. We all have studied about conservation of energy and momentum, but we don't know how they are conserved. So this can be only explained by symmetry. I hope you guys have now understand what is symmetry. As we understand till now, symmetry explores conservation of energy and momentum. But now we will consider the parameter of symmetry in physics. As we delve deeper and deeper into the particle physics, we choose C and P as the parameter, where C stands for charge and P stands for parity. Now we will understand these two one by one. Charge symmetry. It means interactions are unaffected if all the charges are swapped. In other words, there is nothing special about what we call positive charge. Nature treats it exactly equal and opposite to negative charge. And parity symmetry means the laws of physics are indifferent to left or right-handedness. To understand this, imagine a giant mirror were held up to our universe, and if we see in the mirror, the z direction would be reversed much like as our right hand becomes our left hand. So there is no such experiment that can tell us whether we are in the mirror world or in the real world. If you basically want to understand how parity symmetry works, then keep in mind that we can't distinguish between mirror world and real world. If you distinguish between these two, then P symmetry violates. Now first understand how C and P symmetry failed, and that lead us to need of CP symmetry. C symmetry means the symmetry of physical laws under a charge conjugation transformation. Electromagnetism, gravity and strong interactions all obey C symmetry, but weak interactions between particle and antiparticle violates C symmetry, which lead us to C symmetry failed to explain fundamental symmetries. And P symmetry failed because we never have any experimental evidence of P symmetry for weak interacting forces. These were elaborated by physicists Lee and Young in their paper written in 1956. So in that year, physics professor Xinsheng Wu of Columbia University had decided to demonstrate this with her husband, who is also a physicist. They cooled a cobalt-60 atom to 3,000th of a degree above absolute zero temperature. Now they apply a strong magnetic field to align all the nuclei with their spin pointing in the same direction. Cobalt-60 is a radioactive and it decays by releasing a beta particle, which is just an electron. And what they measure was the direction in which these electrons were emitted relative to the spin of the nuclei. To see how this would work under parity symmetry, let's consider the mirror image version of this experiment. We know that the direction of the z-axis is flipped, but the direction of the nuclear spin is not, because if the atom is rotating in clockwise direction, then in the mirror it is also rotating in clockwise direction. So at this position we can't distinguish what is real and what is image. When a cobalt-60 nucleus decay and emit an electron, that electron have 50-50% probability to go to the left or right. Up to this situation, it seems that it follows P symmetry. But when we preferentially say electron goes in the positive z direction, then in the mirror electron is also goes in his positive z direction, which is opposite to the original positive z direction. So in the normal experiment, say electrons are released opposite to the spin, but in the mirror experiment, electrons are released in the same direction as the nuclear spin. So what you understand by this? It allows you to determine whether you are in the mirror world or not. This is exactly what Professor Wu saw. This is not only does the weak force violating parity, it comes close to the violating parity as much as is physically possible. Now we will move on to CP violation. The idea was if the mirror flipped not only these axes, but it also swept the particle for antiparticle with their charges reversed, then the symmetry would be restored, and the mathematics behind our laws of physics would still work. But in 1964, it was found that some particle can also violate the combined charge parity symmetry. Now two rules which physicists once thought were fundamental laws of nature were broken. So they retreated their last set of theoretical defenses, combining symmetry of CPT, where T is a time. Till now there is no another theory or experiment have been done which can violate CPT symmetry. If in future CPT symmetry get violated, then we have to rewrite the special relativity and quantum field theory. As we can see, in CPT theory, C and P are violated. Then there must be that T symmetry would also be violated. Let's see how. Suppose when a pair of quarks are held together by the strong forces, there are sometimes two different possible arrangements and they can switch back and forth between these two arrangements via the weak force. But switching in one direction takes longer than switching back. So if you record this event and play it forward and then reverse, it would seem different. That means it breaks the time symmetry. Hence CPT symmetry is the most absolute theory which can imply the difference between the properties of particle and antiparticle, and it can also lead us to the discovery of dark matter and its atom too, like axions, WIMPs and machos. The CPT theory predicts that the gravitational mass of the antimatter is the same as that of the ordinary matter. So guys, that's all for today. If you like my today's topic, then subscribe my channel and like this video. And do you hear that we have finally found a lake full of water on Mars? If you have not seen that video on my channel, then go and watch now. Link is in my description and in the iCard also. Once again, thank you for watching.